Okay, welcome everyone to our Ask the Expert panel event. The topic, which I'm sure you know, which is why you're here, is why track busway is the future of data center power distribution. We've invited everyone to send in questions, and we've had a substantial quantity of those. So we will be covering, I think, about 15 or 16 today, and we are aware there are plenty more, but they will be followed up offline. Before we start, clearly it'd be good to introduce the folks that are here, which is Rob, JP, and Joel. So I'll ask them each in turn to introduce themselves. So Rob, if you can start by introducing yourself, please.
Yeah, good day, Philip. Good to be here. Name's Rob Hawkins. I'm Senior Applications Engineer at Starline. Been here now 5 years within Starline, and my history's within the data centers industry since 2008.
Excellent. And JP?
Thanks, Phil. JP Berger. I'm the Critical Power Sales Director for the UK, responsible for the Starline brand. Been with Starline just over 6 years now.
Okay, and finally, Joel.
Hi, yeah, thanks for having us on. Name's Joel Farrington. I'm UK Sales Manager for Legrand Data Center Solutions in the critical power portfolio, and we've been with Legrand for just over 3 years now.
Excellent. And just so everyone knows, we've got sort of three broad sections for the questions. The first one is a sort of general set. Then we're looking at application and selection of busways for projects. And finally, we're looking at some technical application stuff. So we will start with the general questions. And the first question is for Joel. And the question is, what is a busway system? Why is it essential for data centers today? And that was sent in by Jan, who's a data center manager in the Netherlands. So yeah, take it away, Joel.
Yes, thanks, Phil. So a busway distribution system is essentially a way of carrying power from point A to point B. Fundamentally, it's composed of the same components you would expect: a conductor, an insulator for protection, and a housing for the system. The key difference between that and many other power distribution systems is the open track element on the underside of the busway, which allows the user to plug in live tap-off units to feed rack power further downstream. This has become more and more critical as the industry has evolved. But basic benefits include scalability from day one deployment up to phase 2, 3, 4 and beyond. Also a lot of flexibility that can come with that, and some design methodology as well. So yeah, a current carrying product that helps deliver power to compute.
Excellent. Thanks for that. And then on to Rob, the next question. This is from Ashraf, who's a business manager from Saudi Arabia. And his question is, what are the latest advancements in busway technology?
Yeah, that's a pretty good question and pretty open, big topic, really, I would say, because advancements are linked to the technology and the servers, right? High density, AI, all keywords these days, and they all link back to the requirement of larger ampacity tap-offs. Brings in addition things to consider, fault reductions and things like that, and the higher amperage busway as well. So for us, the Starline product is at the moment, it goes up to 1250 amps, but we're working and designing. We've got a group of engineers that are in R&D development of even higher amperage busway systems to increase that high density rack deployments. And with that becomes certain issues and safety concerns. Now the product's all live and compliant to every international standard for live insertion. But for those applications where you're getting higher amperages and you want your employees further away from any incident energy arc flash boundaries, I should say, we now have developed a remote actuator, which basically allows the operators to mechanically connect the system, but electrically connect it well away out from any injury arc flash boundary. And there's other systems like power monitoring platforms. We've recently released the M70, which helps to monitor and load share planning, etc. So there's lots of improvement around the systems.
Okay, thanks for that. And next question is Liam from Thailand, and he asks, and this is, sorry, to JP, does the track busway supply power directly to IT racks, or does it pass through the PDU first?
Interesting question, Phil. Yes, it feeds the PDU within the rack. The simplest example I can think of to understand the philosophy of it is like your ring circuit in your house. You have a plug on that ring circuit. So if we think of the busway system with a tap-off point, but that tap-off point is going to feed a point on, within the cabinet. And at home, if you wish to plug in multiple devices into one socket, you would use a multi-plug. So if you think of a multi-plug being in a cabinet, that's the same scenario, to be able to distribute the power up and down the cabinet to the various servers.
Excellent, thanks then. And back to Joel for this one. So Clarell, he's a sales manager from Mauritius, and he's asking, could you explain the key advantages and the disadvantages of using track busways for data center solutions?
Yeah, sure. This is obviously clearly something we love to talk about, and actually feeding on from some of what Rob's spoken about, I think bit of a backward, but starting at the end in a way in terms of the benefits. But one of the things that we're seeing is the ampacity requirements per rack are obviously so large now, which I think I want to raise the point isn't necessarily a new thing for some applications. You know, research facilities have been running these larger loads for quite some time, but it's become very much something that has become normal practice for other data centers in the market. And because of that, in combination with using a track busway system, we're finding high ampacity loads across a large deployment. So we're needing, let's say, 125 amp 80 and 125 amp tap-offs to feed larger loads. When you look at it that way, there's kind of it becomes less of an advantage and disadvantage and more of a need to use a busway system in order to deliver the power that's needed. There's very little alternatives. For more conventional, more historical applications where you've got a lower load, yes, there is perhaps a PDU and cable option, which would in some cases impede airflow on legacy deployments where they've perhaps got downflow units, which is obviously less common now. But that's certainly not a factor with the track busway system that would run overhead. You can see a lot of benefits from that. There's a great deal of flexibility and bespoke design available in the tap-offs themselves, which feed the racks, and that can mean a number of things to a number of different parties, right? So for a colo facility, they have a busway installed. Client A leaves tomorrow, client B comes in the day after that, and they need not rip everything out and start again. They need just replace the tap-offs for the specification that is needed for the new compute power. We can go on about this for quite some time. I mean, another one would be perhaps speed to deployment. It's certainly the most rapid way to get power to compute. In the world that we live in now, where program is first, let's face it, program is first right now. I think that has to be one of the key benefits. I think visibility is another key thing. We have monitoring systems, as you can monitor and meter everywhere. That's not a new thing. However, being able to do that at the busway system, being able to walk along the suite that you own, look up and see the power usage associated or the power anomalies associated with each busway run or rack is tremendously concise from an operation standpoint. So I could keep talking all day about this, and I would encourage anyone that's watching to maybe engage with us on their facilities, and we can kind of hone in on the the specific benefits that that really tie into their business.
I think quickly, Joe, I think adding onto that is to summarize is you can get more power in a smaller, more condensed form in reality, right? Thinking of how many cables you'd have to run for 1,000 amps for a row and how small our Busway system is. That's really the main advantage you'd be considering in this day and age.
Yeah, absolutely. Yeah, and it's very rare, isn't it, Rob, that we look at applications that are lower than 1,000 amps 630. So it becomes a necessity, I would say, at that point.
Agree. Yeah, it's very becoming market trends are going that higher ampage routes for sure.
Okay. Next up, Graham, Associate Director from the UK, and this one is directed for Rob. How resilient are busways? So I guess potentially another advantage. How resilient are busways to downtime during repairs or replacements?
So it's a bit of a broad question, I'd say. So resiliency is really has to be designed in, at day one with the data center design and build process. But if we're going to sort of hone in on just busway systems, like the Starline product has been in market for a very long time, and it has a very high mean time to failure rate, which is calculated by how many busway systems have we been sold and how many issues have been returned to us, and that figures in sort of 700 years sort of factor at the moment. The system itself, if you needed to, as Joel said, need to hot swap a system because your customer now needs to upgrade their power requirements, you don't need to power down the busway. You can live insert and remove that tap off, going from a single phase 32 to a 3-phase 32 to increase their power requirements without any powering down of the system. It does make it quick and easy, really. So I don't think there's basically busways are very resilient in that term of things. If you needed to power down and replace a busway system completely for any reason, as you wanted to upscale and go from a 250 amp to a higher amperage system, that itself would take a period of time that would be quicker because the busway systems are quicker and easier to install than a traditional RPP cable and whip process as well. So I think to answer the questions, I'd say they are very resilient in as long as it's designed in day one as well. But the busway systems themselves are very resilient in being hot swappable and getting your customer back up to powered on and up to speed if they ever needed to increase.
Just one of the things to add on there to what Rob said, the great benefit of the Starline busway is if the customer did have a 250 amp busway system, and through the evolvement of where we're going with the power requirements, wanted to install a 400 amp or a 630 amp busway system, the tap-offs are integratable between those systems. In fact, it's usable across the entire Starline T5 range from 250 to 1250 amp. So your resilience is built in there with that busway to tap-off system.
Okay, back to Rob for this one. Mohammed, an electrical manager in Saudi Arabia, asks, do you recommend using 3-phase or single-phase busways for data centers?
So I've not seen any single-phase requests in reality. I've seen single-phase requirements for rack PDUs for lower kilowatt ratings. So really everything's really built around three-phase busway systems is the most efficient way to bring power to your rack, and the ability to then load share accurately across several racks. So, and you can tee off of that 3-phase system with single-phase tap-offs that are phased accordingly, to your L1, L2, L3, so you get the correct load share on your busway. So it really is, 3-phase systems.
We come across this as well, don't we, Rob, when it comes to call it design assistance or design advice, not design responsibility, sure, but we will generally default to load balancing across equal phases for tap-offs, but where single, on the odd occasion, it is quite rare now because the load of the racks, single phase tap-offs are required. We'll tend to engage with the client when we see how they want to balance the load based on what they've got in legacy. It's not always an exact science, is it? So we kind of apply an engagement with a client on those instances.
Okay, thanks, folks. That's the sort of end of part one, if you like, the general questions. So now we're moving on to the application and selection of busways for projects. JP, you're up first. So Rene, an account manager from Nicaragua. We've obviously got questions coming in from all over, which is great. So the first question is the implementation of busways in smaller data centers as efficient as in hyperscale facilities?
Phil, that's a very broad question and an interesting one at that, because I think data centers, um, each site has its own unique power requirement. You couldn't compare the requirement of a colo to a hyperscaler for their demands and needs. They have different requirements. So my answer to that would be every application is unique to itself. And I do believe that in a small data center, Busway can be very efficient, yes, because you can have special requirements for changing out of cabinets over a short period of time in a small data center as what you could in a hyperscaler. You could argue a hyperscaler is buying hundreds of meters, if not thousands of meters of lengths of busway, but a small busway in a data center might only be 20 meters long. But it all comes down to the application for that customer, the resilience they want in their system. So you can quite easily, without having in a small data center, you wouldn't have the infrastructure for running loads of cables and cable management systems. So the simplest solution, in all honesty, in that case, is a busway system.
Okay, and I suspect this is not unrelated. Lucas, sales director from Czech Republic, asks, and this for Joel, is Starline a feasible product for non-hyperscale data centers, therefore?
Yeah, it certainly ties in, doesn't it? The answer, if it was a closed question, yes, it is suitable. And you have to look at it on a case-by-case basis. Like JP mentioned, you have to look at the holistic view of the data center, what the usage is going to be like, et cetera, in order for you to decide what is meant by feasible. But absolutely, I think we obviously know we've supplied many projects in enterprise data centers, for example, and that might be for a different reason. They might want flexibility from the standpoint of they're running, say, testing procedures in the racks, and the tap-offs get quite a lot of usage, and they have to swap those out, as opposed to selling the space and client B coming in place of client A. So the feature is the same, but the benefit is different, and therefore the feasibility becomes very personal to each individual facility. I think when we look at enterprise as well, just as another extreme example, because obviously we're not discounting traditional colo, retail and wholesale colo here, is control. The one thing they want is control for the data centers. So this, there's not a better product in terms of control and visibility on the market in a way of accessing the power. So yeah, the short answer is yes, but there's obviously a lot that goes around that, right?
Yeah, and I think to add to Joel's point, a lot of customers that don't work in the hyperscale space, they always perceive a data center as this massive shed. If I don't have a big shed and loads of power running to it, well, what type of data center do I have? Or as the previous question from Rene, will that class as a data center for the use of Busway? Yeah. But if we just look at where the market's going now, having big sheds for high power compute is probably is not, the two don't go together. Data centers are going to change to all shapes and sizes. It's the power distribution, regardless of the application thereof, for those cabinets, and that's what Busway is perfect for.
Okay, and if we can stick with yourself, JP. So Antoine, sales manager from France, on a slightly different tack, he asks, if a site has a lease agreement, are busways removable and reusable once installed, and do they have a defined lifespan?
So we do come across this question quite a few times, and Rob will probably back me with how we approach these types of inquiries, because in the traditional sense of the leasehold, the busway will sit there for 20 years comfortably and service that specific client's power requirements. And if you look at a colo arrangement, even where there's a leasehold, there could be multiple tenants all using in and out using the busway system. The first thing we would say is, yes, you can look at removing the busway and installing it in another application. But this is where Rob is very pivotal to this and critical, because we need to fully assess if it is even possible. Will it suit the environment? Will it suit the application? Is that fair to say, Rob?
Yeah, you're right there, because yeah, we've had some clients who've removed lower amperage busways to upgrade, and then they found a use for that lower amperage busway somewhere else. And it's just a case of assessing, making sure it still meets the design requirements for that application. And as long as a certified technician is there and does the inspections, certain critical components are replaced. But yeah, it's reusable and recertified as well with the Starline product is, for sure.
Okay, and actually sticking with yourself, Rob, here. So David, head of data centers in the UK, he's asking, are busway systems compatible with data center projects across both the UK, I guess, and Europe?
So the basic answer to that is yes. The busway systems are designed and built to IEC standard. 61439 section 1 and section 6 is the busway specific section. So this means it covers any IEC world, which is anywhere in Europe and APAC as well. So yes, they are interchangeable. You have some regional considerations to consider. Some regionals must have a switch neutral application. So you may have a slightly different tap off between borders, but you can try and standardize and as much as possible with that. And luckily, if you're running a large facility and you've got the Starline product, for example, across regions, you can intertransfer tap-offs for critical spares and keep your critical spares more reduced and centralized, maybe for a specific region. So yeah, it's yes, you just got to consider regional regulations, which your electrical designers would at the time of designing, right? So
this is definitely where having that universal tap-off design to fit all the amperage of busways as well, and all the projects across the UK bears fruit, because you haven't got to redesign everything. It's just a matter of flexibility within the tap-off design, right? That's definitely something we see as a benefit.
Okay, thanks. And then back to JP for this one. So Manohar, design engineer from Ireland. I hope I pronounced his name correctly. So the question here is, when comparing track busways and PDUs, which option is more cost effective?
Very interesting question, Phil. We do get asked that by customers who are not that familiar with the busway system, and it's an interesting perspective on where does the cost actually lie, because busway, the application thereof is the speed of installation, the speed of deployment, the flexibility. And if you just look at the design aspect of the traditional PDU and whips, there is already a massive cost difference for the flexibility for the future, because that PDU or RPP whip arrangement has a great limiting factor. Any change at any stage does require significant investment in labor for removing and installing new whips, perhaps more cable management. The whip arrangement, if it's in the floor or above the cabinets, which we sometimes see, requires a significant investment in cable management for transporting that power, which a busway system eradicates. But a lot of people will look at that question at the front end, and they want to look at the product and say, well, if it costs 10 grand for that, it only costs 7 grand for this. Or but there's a much bigger picture. We've done a number of studies on a 40 kilowatt and an 80 kilowatt design comparison. And we found that anywhere between 15% and 30% cheaper going with a busway system rather than with a traditional.
Yeah, just to your point as well, are you able to have intelligent conversations with people as to, CapEx versus OpEx, or do you still get a few too many accountants just say, well, this is cheaper up front, therefore that's what we're going to go with?
That's very poignant.
Yeah. It's we do get that, and that's when they are literally just looking at it at the front end. And again, it comes down to application. If some applications are literally looking at the upfront cost and they want to put something in on day one, they don't want to ever see the busway system. It's almost as if they're looking at a truss in a ceiling. I see it, but I don't really see it. And quite often we have to do a cost comparison with those particular types of clients, but we have to work with them on understanding the principles of what they could achieve with a busway system versus just going for that day one limited factor.
Like we find ourselves having these kind of coaching conversations, don't we, JP, with the customer base, and because obviously there's that division of capex and opex, and is it the same person holding the purse strings? And sometimes it isn't. But I think we talk a lot about sustainability right now, and I think if we're actually going to be sustainable, the market should definitely join up on those things, and have those capex and opex let's say conversations and decisions made in a joint manner, in a holistic manner, because that these savings are, when you look at them, are holistic. They are, as JP said, the bigger picture stuff. So I do find actually that most of our customers are very receptive once we've highlighted, and we're actually bringing to their attention things they hadn't appreciated. Some of it they have, other parts maybe not. I know, Rob, you do designs like this all the time, and I think you get some raised eyebrows, don't you? It's always fascinates me to see how people think, oh, okay, I didn't think about that. And it's quite interesting. It's when the job becomes a lot more exciting when we actually get to lead the design and help drive true value for our clients.
Okay, and sticking with yourself, Joel, so Ulrika, an editor from Germany. So the question here is a busway solution only viable for new data centers, and how long does it take to see a return on investment? I guess again that's a fairly open question, but
yeah, I think it is a broad question. The second part, we can, I think, refer back to the nominal calculations done by the studies in the previous question for the ROI. In terms of new versus legacy data centers, we do, I would say, equal projects for both. The biggest difference that I see, and we probably see as a business, is let's say the upstream infrastructure. So is the switch gear. What can the switch gear deliver further upstream? What power have you got available? How is that being fed? If you're limited to 250 amps per stream, then you're limited to 250 amps per stream. With a busway system, you can do creative things. You can have a legacy site, let's say an end feed from end A and an end feed from end B, and you'd have actually 4 streams, 2 for A, 2 for B, for example, to double up on your availability. For most new builds, I would say it's quite rare to be looking at anything less than 1,000 amps at the moment. So the solution viability is different for sure, but I think the speed to deploy for legacy is a huge factor. We've fit out a number of halls with actually quite a high amperage 630 amp product, and that's a lot largely down to the good work done by the contractor as well as us as a manufacturer to produce the product. But yeah, the viability transfers depends. It means something different to different clients, but I would say the usability is definitely viable for both new and old as a general.
And if I can just add on that, what Joel said there, Return on investment's an interesting statement, because it means, like Joel said, different things to different people. But ultimately, when I spend my cash, how quickly do I get return? The greatest thing about Busway is that with your Busway installed, you don't have to procure all the tap-offs until your client actually signs on the dotted line to take the space. So where in a traditional design, you could be looking to procure all your RPPs or PDUs up front, put all your cable management systems in, run your whips on the design of what you believe the client is going to be taking in that space. If you have done that calculation to a particular customer and another customer wishes to take space with a higher power requirement, then that's going to be a very costly affair if you wish to entertain it, or you cannot entertain that customer at all. Whereas with Busway, you have that flexibility to put the backbone in and not a single tap off until your particular client signs on the dotted line. And we have a great way of working with end users to understand their requirements ahead of time. So they pretty much standardize on what they would like to see per cabinet based on the kilowatt demand. That allows us as a business to gear up and make sure we can meet their lead time. And then your return on investment is pretty quick, I would say, because the moment your client takes space, you're supplying him a tap off and your return is instant.
Yeah, it's very true.
Thanks. So that sort of concludes the second section of questions. So we're on now to the technical application, and this is a sort of monster question. Well, I think it's 3 questions in one. And Rob, you're up for this. So Valarasu, solution architect from India. So I obviously, if you forget one of the questions, just let me know and I'll remind you. But so here we go. So part 1 is, what are the best practices for load balancing in a track busway system? Then we have, how is heat dissipation managed in track busway systems to prevent overheating? And part 3 is, how do you monitor and control the temperature of track busway components?
Okay, yeah, that is a monster question, right? Yeah, for sure. So what was it? Load balancing first, right? So yeah, most systems are 3-phase, obviously, or 3-phase busway track systems. Most outlets these days are 3-phase, right? So load balancing doesn't really come in there. It comes down to monitoring, I'd say, in reality, really, and being able to monitor your busway system so you can put effective practices in place. So it starts with day 1 about design, right? I'd say. So initial designers need to understand your rack loading and how that's going to be distributed. Most information is just provided to them is, I need a 50 kilowatt rack, or I need a 22 kilowatt rack, right? 22 kilowatt rack is a 32 amp 3-phase tap off. But you may not know at the design stage how they're going to distribute their load within that rack. So we're just feeding an in-rack PDU. So again, it comes around demarcation as to where who's invested in the busway, what points you want to monitor. But in reality, if you monitor the end feed, you can then get the whole view. And then if you can monitor every tap off with power monitoring, you can then easily map how your customer is utilizing the power that you're providing them. And then you could advise them that you're too overloading, you're getting close to L1 limitations, you need to start loading L2. So can you look at how you're plugging in your servers into your in-rack PDUs, because you're causing an imbalance, right? So that's the main big sort of question, is just you need to be able to monitor, see what you're doing. So intelligent PDUs are great for that. But if you don't have access to that, as if you're a colo provider and you don't have access because that's the customer's information, then you do need to be monitoring off the tap offs for sure in that one. I think that covers that really for that load balancing. It's all about monitoring in reality. And was it heat dissipation? Correct, right? Yeah. So heat dissipation, right? So yeah, so as the amperages are getting higher, correspond that to being more heat being generated by the system, and that heat needs to be removed from the data center environment, right? So first of all the busway systems are tested, as said, to international standards, and we do provide power dissipation values per meter of that busway system. So it's really coming down to the designers to map that accordingly within the room environment in stage 1 to be able to remove that heat from the room. our system is a single case of aluminium as well, so that certainly helps. And the IC standards all around an ambient temperature of sort of 35 degrees within that room. But obviously, our Starline system is actually rated higher, up to sort of 50, 55 degrees without sort of any derating in the Busway itself. So you can sort of bear that in mind when they're doing the studies within that dissipation. But we've mounted busways in hot aisles and cold aisle containments, right? And you just got to have a derating factor against that. But really, that comes down to airflow and dynamics within the rooms, really, which is sort of a bit out of the warehouse for us as a OME provider of the track busway. You're relying on other systems and the within the room conditionings. Now we can cover though monitoring, right? So monitoring of the system. So the way to monitor it for us is our power monitoring solution here at Starline, the M70 series, has actually the ability to temperature monitor that busway connection. So that will give you real-time data via Modbus back to your building management system, or that can identify an alarm if there is ever a issue with that busbar system. So, pre-alarm somewhere, probably, if I remember the top of my head, around 80 degrees, you can have sort of a preset, and then you can set that higher or lower value depending on the ambient in the room. So it makes it really easy to be able to monitor and control the temperature of the track busway system there within the end-feed and real density. And there's other systems and availability that you can monitor systems. Also, yearly infrared scanning of the system will help you identify any issues or occurrences there. But it kind of links into load balancing, right? So as long as you're monitoring and accurately distributing load evenly across the busbar system, you shouldn't really have a temperature issue at all.
I think it's quite important to mention that with the new regulation coming in, I'm going to sound probably like a broken record because everyone's talking about it, but it really does increase the relevance and the need for metering and having usable data at, say, a rack level that would feed a tap off. So I think accuracy, real-time data, that our range of meters are extremely accurate, twice the accuracy of quite a lot of others on the market. So I think making sure that we have some data to use to make informed decisions on idle systems and trying to eradicate waste and address the real-time challenges in regulation, I think is really key.
Okay, so yeah, Rob Henry, quantity surveyor from the UK, asks, how do the time and cost required to commission a busway system compare to traditional power distribution methods? Yeah,
okay, so it's commissioning's sort of commissioning, right? You've got a certain criteria that you've got to meet and sign off. I think that the real benefit with the busway system, it's quicker to install, so therefore the commissioning process should be in itself a little bit speeded up anyway alongside that, but you still got to complete the same tests and verifications, but you have maybe less circuits. So you've got one end feed connection, 15 meters a run, and you've got one insulation resistance test, one continuity check to do, rather than with the RPP you've got to obviously check and test every single circuit coming off of that to the point of connection. So there's a lot less points to test, should I say, and also to sort of peace of mind there with the tap offs and everything like that. Everything goes through a solid routine verification test in the factory that includes ground bond, high pot, and functionality testing. So they do come out of the factory with the tap offs, even that you can just directly insert into live bar with that extra safety and verification with a full report from the factory. And then, regional regulations will require you to do some live testing and other on-site tests. But it does speed up the process having a busway system compared to a traditional RPP.
So thanks for that. So JP Mohammed, electrical manager from Saudi Arabia, asks, can busway solutions be installed in floor telecom rooms? And indeed, are they recommended for telecom providers?
Phil, yes, the straightforward answer is they are suitable for telecom providers. We do have Starline Busway deployed in a number of data centers for telecom operators. The first part of that question relating to Busway being installed in a floor, yes. Again, we have a number of deployments where the Busway is, because of the height in the floor, the Busway is installed on its side, and we have a specific way of mounting the tap-offs. And if we have very limited rotation circumference to be able to insert the tap-off and rotate it in, then the remote actuator is a great advantage for fixing the tap-off to the side-mounted Busway, and then using the remote actuator to carry out the function to mechanically, electrically engage the tap-off into the Busway. So absolutely. And if anybody wants to see any examples of that, we have our showroom in Reading where the Starline Busway is manufactured. And we have a sample of Busway under a floor with some tap-offs, and we can show customers how that is achieved.
Just going to jump in there quickly. So, say about telecoms. Telecoms is mainly DC, I believe, sort of around 48 watts. So bear in mind, we're all talking about power and consumption of the Busway, but the Busway can be used for AC or DC power distribution systems, instead of having 4-pole system L1, 2, 3, you'd have 2 DC circuits in there. So we've done a lot of applications and can do DC applications for that as well.
Perfect, thanks. And Joel, Walter, an electrical engineer from the UK, is asking, are there any studies or projects comparing the use of cables versus bus bars when it comes to data centers?
Yeah, I think there's quite a lot of inspiration to draw on here. It's a nice way to, it's a nice thing to follow on from everything we've spoken about, because inspiration to draw on of, JP mentioned about the investment in cable management above rack, should you need to go above rack with the cables. We've spoken a little bit about the cooling impedance that could be brought about if you do run the cables under the floor, for example. We can look a little bit at the time to deploy. And then there are the intangibles, like as JP referenced, you might have a day one deployment, you put the PDUs, the whips, you run everything in, and the customer changes, and you've then got a decision to make as whether you can facilitate that customer or you have to turn them away. So that's more of an intangible. I think because of the holistic picture, the zoomed out picture, the bigger picture, we really do find that this is a body of work that tends to be taken on by a contractor, either an engineering firm or a PQS or both, and they tend to embark on these. I think not all of which we see, by the way. Some of these studies we've done, high-level studies, the figures we can draw on from JP's reference earlier of up to 30%, for example, in terms of a benefit, but not all of them we see. I think the biggest advocate for busway systems against cable is the amount that we see in the market. And there are, doesn't mean to say that 100% of applications are using busway over cable, but it's certainly the rule to use busway and the exception to have cable deployment. So I think it's just testament to the viability of the power distribution strategy. It just makes every bit of sense to pretty much every user.
Excellent. And I think there's just one bonus question, which I think we've got time for. And Rob, you're up again. So Francis, power engineer from Uganda, and this is potentially a whole new conversation. So, but I'm sure you can give us some bullet points. But the question is, how can harmonic currents in a data center be effectively controlled?
Dreaded word of harmonics, right? I think it's more related to potentially older, less efficient equipment, that injected unwanted harmonics into the sine wave, into the system, power system, should we say? So it's not really something overly rated that the busway system can mitigate. We have the ability to have 200% neutrals for when it can't be designed out in any other way. So that's the only really thing we can contribute to the busway. You can have high quality power monitoring systems, that can try and detect any harmonics. But we've had, how can it be controlled? Really about monitoring again is probably key thing about monitoring in it. and understanding what type of equipment's being plugged in. I think in reality, for arguments, we've done systems where we've provided power supplies to rear door coolers, and they provide a lot of fans and motors, for cooling capacity, but they themselves are regulated very strongly and have to have pass testing that make sure that they don't inject harmful harmonics into power systems. So everything's got more efficient and better in itself. So yeah, it is probably an issue these days in some data centers. And I say the key is to understanding what loads you're applying to your Busway to be able to monitor it and use it. And you can sort of design it out obviously further upstream with the uninterruptible power supplies and power factor correction units and things like that. So it's a whole topic that I am nowhere near an expert on or level in, but that's my understanding. And my recommendations would be monitor is key in this day and age to understand what sort of loads you've got, and then you can correctly act on that information.
Before everybody disappears, Phil, I just got a couple of things to do my marketing bit, if that's okay. Yes. First shout out is that the Legrand team will be at Data Center World London XL 12th and 13th of March. We'll of course have the Starline Busway product where customers can come along and talk to our product experts. Joel, Rob, myself will be there. Plus we'll have a number of other of our Starline colleagues available to engage with customers and talk about their applications in more detail. And then we also have a dedicated Starline event on the 30th of April in London near Charing Cross, and that will be a great opportunity for our customers that would like to know more about RPP versus Busway, would like to discuss more of the technical aspects, specifically relating to queries they might have, and a bit of an opportunity to get to know people more. So we'll send out some information about that, and customers can register to attend the event.
That's fantastic. I've already been told to keep that date free by one of your colleagues. So
perfect.
See you all, well, some of you maybe at Data Center World, but again, thank you to Rob, JP and Joel. Fantastic to give us so much time and share your expertise on the topic. So thank you very much for that. And of course, thanks to everyone who's attended to listen to the online event. So thanks to all and goodbye.